that may actually be bigger than you want. If the problem here is 20% can be a lot in a big table. And so somewhat paradoxically, you may discover that the thing with 20% was fine when it was a small table, but now that it's a giant table that's a huge amount of work to vacuum, I needed to vacuum more often because 20% of it is just way too big of a number if I let that much out of the 30. Vacuum is intensive when it happens, and you can't put it off forever. There is this concept of a transaction ID number in Postgres. It can only get to about 2 billion before the database has to do some internal cleanup to reuse those transaction ID numbers. It's a process called freezing. And so it takes transaction IDs that it definitely doesn't have to care about the visibility information on anymore and replaces it by what's called the frozen transaction ID. So the thing is, you can put off regular vacuum. You can't put off frozen transaction ID cleanup, because if that number ever rolls over inside the database, you're done. You can't start the database anymore. You can't process transactions. So even if you turn auto vacuum off and you've done all sorts of things to try to stop auto vacuum from running, it will still do transit. It will still do frozen transaction ID cleanup when that threshold is crossed. And that threshold is actually 200 million by default. So it will start kicking in and trying to do this when it's only gotten to 10% of the point where it absolutely must do it, or the database server will crash. So it's a little paranoid. So the bad cycle that some people get into with Postgres is they'll run the server, and then one day auto vacuum will kick in. It'll have 20% of a reasonably large database to clean up. It'll be really intensive. Like the server will get hammered. People are complaining. The phones are ringing. Why is the server so slow? So people go, "Oh my God, vacuum sucks. Let me turn that off." So that works fine for a little bit. And then one day, frozen transaction ID kicks in.
Dun, dun, dun.
And now, the magnitude of the problem that you've got is probably at least 10 times as big as the one you had the first time you started the transaction. And you can't stop it no matter what you do. So you don't want to do that. What you want to do is, it's possible to take auto vacuum and put limits on it. It has these things it calls cost parameters. They're not in good human readable units. It's not like it says, oh, only use this many megabytes per second. It works in theoretical costs with estimates for how much work a page takes and stuff like that. You're going to have to practice a bit to get the right numbers for your workload, but you need to do it while you've got a smaller database, and you want to get some practice with this, because when you've got a giant database, it's going to be much more difficult to do. So the concept is not, let me delay this, because you can't delay it forever. All you can do is make the problem much worse by delaying it. What you can do, though, is you can try to smooth it out and make the whole thing not be as intensive when it runs. So really high volume sites will end up in this situation where the vacuum is basically always running at a really low intensity, doing something like that. Because you can never get to a situation where you can let it spike, but if there's enough churn in your database, there's always something that needs to clean up. You also can combine this concept with some manual vacuuming. Like if you know, hey, wait a minute, my workload is typically lower at this point in time, you can say, well, let's launch a manual vacuum with this cost limit and intensity that's a little bit different than the automatic one, and let's let it go a little bit harder at the server during this window than it would during the rest of the time. And there's even like in Simon's book here, he's even got a little recipe for crazy things like changing around settings in PostgreSQL.com to have the server is mission performance critical, and a server can do more maintenance number, settings based on what time of the day you're in, or whatever it's like. Not only will delaying the problem make the problem worse, this dead rows stuff, these things, they cost you something. The dead rows in the background, even though they're not active anymore, when you're scanning information in the database to try to run queries, those things are slowing you down. And that slowdown is adding up the more and more dead rows you've got. And the word that gets used for this a lot is we call it bloat. You know, bloat is a chunk in a table that's just not actually used anymore. And bloat can end up becoming significant. The thing that you don't want to do is something I ran into at a former company at one point. We'd accidentally added a bug to the version of Postgres we were shipping to a customer that caused vacuum to never run. And when we finally realized what was going on, there was actually a terabyte of dead rows in the database. Don't do that. That's really bad.
How many non-dead rows were there in that database?
200 gigabytes.
Yeah.
Exactly.
Got a question.
All right. So question first. Then.
Okay, I'm just trying to get this straight. Maybe I missed something, but if I'm updating or deleting a row, you said that might be needed in that another transaction. Like how would I be allowed to update or delete a row that's being used by another transaction?
The whole underlying implementation in Postgres, this thing called multi-version concurrency control. Everybody gets their own version of the row in situations where multiple versions are needed. Okay. That's actually how it ends up working under the hood. So you can have two versions of a row. This one's visible to this transaction, this one's visible to this transaction.
And then when that transaction ends, then it's no longer visible if
once eventually it ends and all other transactions from that era end, and then it can go clean it up, but it has to wait for all the transactions.
Okay, so what if I have sensitive data that must be deleted now, and I don't even want to, like I guess if you're doing that vacuum, before you do that vacuum, I guess there must be a way to get that data back.
That's, yes.
So what if it's sensitive information that must be revoked forever, and I don't have time to wait for vacuum operation?
Yeah, you'll be hard pressed to eliminate data from a database that you can't recover it by doing an operating system level dump of that data page. That's actually the hard thing. Even if Postgres released it back to the operating system, there's no guarantees the way Postgres does I/O that the operating system is actually really going to overwrite the original copy of everything. For example, if you're using a file system like ZFS, ZFS does something that's called copy on write. When you write something back out again, it also makes a new version of the thing, and the old version is still there. It just, after it's finished the new one, it stops making it available, but that thing is still sitting around there. Doing secure deletion on writes, there's an operating system layer to that as well, and that makes it difficult for Postgres to really enforce anything. So even if I told you, here's what you can do to make absolutely sure of what Postgres is going to do, because Postgres is doing all its I/O to the operating system, you'd be hard pressed to be absolutely sure it's not still on disk if someone did on the file system.
Yeah, even dropping the table is just unlinked with files on the file system, they'd still be available if you actually went and scrolled through the inode table as well.
And if you take your disk drive out of your database and you ship it to somebody, they can even recover blocks that have been overwritten on the disk if you're willing to pay enough money for it.
I can understand
so
that.
it's hard, but yeah, it is something you may want to look at. And if this is a concern to you, you definitely want to see Bruce's talk, because he actually talks about mechanics of this. Give me 1 second. You had a question over there. What was our next one?
Just a quick one. You were mentioning earlier that an update actually results in two shadow rows being created.
Well, not two shadow rows. You've got the original row. It's just been marked deleted, and you've got the
Testing in terms of that, I don't understand the question. So does that mean that if you do updates, there's two rows that are impacted by the update? Would that mean that would count twice as
it's the new ones that get added are what gets used for that counter. And I glossed over one thing here as well, which is the threshold for updates and deletes triggers vacuum when that many updates or deletes have happened. It's like, okay, we're over 20% of the table relative to how many rows are in, let's do that. Whether it's going to do analyze or not is actually also considers inserts as well, because your database statistics will get out of whack if you insert a bunch of data. So Postgres keeps some internal counters for how many rows have I updated or deleted. You know, you can actually see them in you can see some form of them in PGStat user